well. Okay, so today we're talking about something called limiting reagents, and we'll get to that, what that is in just a second, but let's start with the stoichiometry. So our starting number is 100 grams of S, sulfur, and it's reacting with excess Fe, ions, which means that we can ignore the Fe, and then we're looking for the theoretical yield of FeS. So that means that we're just going to do stoichiometry to figure out how much FeS that 100 grams of sulfur is going to make. So we're just going to set up our stoichiometry. So 100 grams of S, we're going to set up our 3 fractions. And then we're just going to plug in what we need to. So again, I'm not going to be going over stoich slowly anymore. I'm going to be kind of whizzing through it. So I'll have all the things you need up here, but going to be going through it quickly. So if you guys feel like I'm going too fast, please tell me to slow down or go over something that you guys might have missed, okay? And since we're looking for FeS, we're going to put FeS at the very end. Okay. All right, tops of the fractions, we do gamamaga, so grams, moles, moles, grams. We know that the first 2 are about the same chemical, so it's going to be moles of S, and the last 2 are about the same, so it's going to be moles of FeS. Okay, so that should be the tops of your fractions, and now all we need to do is plug in what we got. Okay, so first fraction, we need to use the molar mass. So on the bottom, we're going to put grams of S. And so if you look up S on the periodic table, it's going to be all the way on the right side. You should get 32.07, but since there's a 0 in the 10th place, I'm going to round that down to 32. Okay, so we're just going to put 32 grams per 1 mole, and the grams cancel out. So again, I'm going through this quickly because we've been doing this for a long time. So let me know if you miss anything, okay? We're going to put moles of S on the bottom. There's nothing in front of S or FeS, so we put a 1 on the top, 1 on the bottom. And then we're going to put moles of FeS on the bottom, and then we're going to find the molar mass of FeS. So we're going to go to the periodic table. We already have S. It's 32.07. And then we got our, where is it? We have our iron right here on the bottom left, or the middle, I guess, 55.84. So for the molar mass, we do 55.84 plus 32, you should get 87.84. So the molar mass of FeS is 87.84 per 1 mole. Okay, so that should be your setup. Any questions about this part? Hopefully pretty self-explanatory. Okay, now we're just going to plug and chug into the calculator. 100 divided by 32 times 87.84, and we'll get a final answer of 274.5. And that's going to be grams of FeS. All right, any questions about that part? Hopefully that wasn't too bad. We're just reviewing what we've been doing. Okay, so to talk about what the topic is for today, we're talking about something called limiting reagents. Now, if you guys notice, every single stoich problem we've done so far, we've always had a number, and then we had excess of another chemical, right? And excess means that we have a lot of it. We have so much of that chemical that we don't need to worry about it. Okay, but what we're going to be doing today is we're going to be learning how to figure out the theoretical yield when it's no longer excess, when you have a certain number for the other reactant, because that's going to change up the way we approach the problem, okay? So going forward, we're going to have no more excess. Okay, instead, we are going to have a number associated with both chemicals. So we can't just ignore one of them anymore. Instead, we're going to have 100 grams or a number for one of them and a number for the other one. And then that's going to determine how we approach the problem. Okay, make sense? Concept-wise? Okay, that's what limiting reagents. Thank you, Parker. Okay. So let's move on to the notes part, and then we're going to go, excuse me, into the actual problem. Okay, so you guys don't need to copy this down. This is just kind of to help us make sense of the concept we're talking about. Okay, so up here I have a chemical reaction for making a hot dog. Okay, kind of like a recipe. Pretty easy. 1 sausage, 1 bun makes 1 hot dog, right? We all know how to make a hot dog. probably wouldn't taste that good because, you know, you need ketchup, mustard, relish, whatever. But this is just the basic reaction. Okay, so pop quiz. If you guys have 3 sausages and excess buns, if you have unlimited buns, what is the theoretical yield of hot dogs? How many hot dogs can you make with that? Yeah, you can only make 3, right? Why can you only make 3? Yeah, you're gonna run out of one of the ingredients, right? You're gonna run out of the sausages. So your theoretical yield is 3 hot dogs. And your limiting reagent, this is the new thing we're talking about. So make sure you guys write this part down. The limiting reagent is the reactant that runs out first. Okay, and that's the definition for the concept for today. Okay, the limiting reagent is the reactant that runs out first. Okay, so if we take a look at this problem right here, Daniel just said that the limiting reagent is going to be the sausages, right? Because the sausages are going to run out first. So the sausages are the limiting reagent. Whatever you run out first, whatever ingredient, whatever reactant you run out of first, that is going to be your limiting reagent, okay? So just make sure you guys write that down. Sometimes I like to write LR just because it's faster, and you guys can do that. You never have to write out the full term. If you write LR, I'll know what you're talking about, okay? Okay, now before we move on, one thing I want to point out is that the limiting reagent is a reactant, okay? If you guys remember, reactants are the things that are on the left side of the arrow, and the things on the right side of the arrow are always the products. So whenever I ask you what is the limiting reagent, make sure you pick something from the left side of the arrow, okay? If you pick something on the right side, that's a product, so that doesn't fit the description. So that's kind of a way for you to kind of clue out what the limiting reagent will be. All you have to do is you need to look on the left side and pick a chemical from the left side of the arrow. Okay? The limiting reagent will never be something from the right side. Okay. Okay, so that's if we have excess of something. We said, though, going forward, we're not going to be talking about excess anymore. Okay, so let's look at another quick hot dogs example to see what happens if you don't have an excess. Pretty easy concept, though. Okay, so in this situation, same reaction. If you have 5 sausages and 3 buns, show me with your fingers what is the theoretical yield of hot dogs you can make. What's the max number of hot dogs you can make? Show me with your fingers. Yeah, 3, west side, right? 3 is the maximum amount, okay? Why can you only make 3 hot dogs? Yeah, you only got 3 buns, right? You're gonna run out of buns. So the reactant, the thing that you run out of first are the buns. So your limiting reagent this time are gonna be the buns. And then you're going to have 2 sausages left over, okay? Make sense? Super easy concept, right? It makes sense when we look at things like hot dogs or things like this, but once we apply it to stoichiometry, it does get a little bit more complicated, but always try to go back to this concept. It's whatever runs out first, okay? Another way to think about this is just looking at the potential hot dogs you can make. If you have 5 sausages, what's the maximum number of hot dogs you can make? If you ignore the other one. Yeah, you can make 5, right? Potentially. If you had unlimited of the other one, you can make 5. But if you look at the buns, what's the maximum number of hot dogs you can make? 3, right? And so if you guys notice, you can make a different potential amount depending on which ingredient you look at, right? But what happens in real life is always going to be the smaller amount. Okay, so you might want to write that down somewhere. You're always going to make the smaller amount. So the smaller amount is the actual yield or the theoretical yield. Amount is the theoretical yield. So this will be helpful when we do our stoichiometry problems because just to let you guys know, you're gonna have to do stoichiometry multiple times. but the correct answer for the theoretical yield is always the smaller number, okay? So I know with hot dogs and things like that, you don't need to think much about it, but once we start doing the stoic and the numbers get really weird, this clue will help you guys find the correct answer, okay? The smaller amount is going to be your theoretical yield. Okay. All right, you guys ready to do the stoic? Yes? Yeah. Yes. No. Oh, not that part. Yeah, different problems. Okay, so you guys don't need to write this down again, just definition so you have it in your notes, but let's do this problem. Okay, so if you guys take a look at this problem, sulfur's not a metal. If you guys take a look at this problem, you'll notice it's basically the same thing as the problem we just did. The only difference is that last time we had excess iron, but now we have 100 grams. Okay. Shh, ladies, I can't hear myself think. Okay, so what you're going to want to do when you see a problem like this where you don't have excess is you're going to have to do stoichiometry multiple times. Now, we already did one of the stoichiometry problems. The first one that we did where we took 100 grams of sulfur and then we did our 3 fractions. And then what was the answer? We got 87.84. Completely off. 274 point, what was that? 5, thank you. Grams of FeS. Okay, so our calculations that we did in the warm-up, they basically tell us that if you have 100 grams of sulfur, this is what you can potentially make. Okay, remember the hot dog example? If you have 5 buns, you could potentially make 5 hot dogs. That's what we can make with 100 grams of sulfur. Okay, but this time we don't have excess iron. This time we have a limited amount. So what we're going to have to do is we're going to have to set up another stoichiometry problem where we start with 100 grams of iron. And then you're going to have to set up your 3 fractions. And then this time you're going to be solving same thing for grams of FeS. Okay, so what we're doing here is we're seeing how much FeS sulfur can make, how much FeS iron can make, and then based on our numbers, remember, we're going to pick the smaller number because that's the actual theoretical yield, okay? So I'm going to give you guys about, let's do 3 minutes. I'll give you guys 3 minutes to solve out this new stoichiometry problem. And then after that, we'll go over the answers and then we'll figure out what the real theoretical yield is for FeS. Okay, so take about 3 minutes to do that. All right, so I'm going to plug in these fractions. Let's see if you guys got the correct answer. So we're starting with 100 grams of Fe. What that means is we're going to put grams of Fe on the bottom. Molar mass of Fe is 55.85. And then we know that it's 1 mole on top. Sorry, I forgot to do gamma, and that's moles of FeS. Okay, there's no numbers in front of Fe, so we're going to put 1 mole of Fe. There's nothing in front of FeS, so it's 1. Okay, and then if you look at the last fraction, it's the same thing as the one that you just did, so you don't need to find the molar mass again. It's just going to be 87.85 per 1 mole. Okay, and then the moles cancel out. Okay. All right, so we are going to plug that into the calculator. So 100 divided by 55.85 and then times 87.85. And the answer that we get is 157.2. I'll just round that to 3. 157.3 grams of FeS. Okay, if you got something close to that, that's fine. 107.2, 107.29. Any of those is fine. Okay, everyone got to that point, hopefully? For sure, most of us, all right. Okay, so if you guys notice, if you look at these two values, you have different numbers for the same chemical, right? You have 274 for FeS, but you also have 157 for FeS. Yep, let's schedule. Okay, so if you guys notice, there's 2 different numbers, right? Now, what did we say is the correct answer? Which of these values should we pick? The smaller one, right? Why do we pick the smaller one? Yeah, exactly. This is the limiting reagent. This is correct. This is the limiting reagent. But the thing is, once we get to 157.3, you run out of Fe, right? Just like the example with the sausages and the buns, you run out of one of the ingredients. If you run out of one of the ingredients, can you keep making the other chemical? No, right? You run out of one ingredient. So that means that even though we could make 274, since we run out of iron, we will never get there. We are going to stop at 157.3. So the theoretical yield in this situation is the smaller number, 157.3 grams of FeS. And then, like Lexi said, like Daniel said, the limiting reagent is going to be Fe. And then Lexi, I didn't even think about that. You're right. But Lexi did tell me, she told me the correct answer. Okay, so the limiting reagent is Fe because that's the chemical that we run out of. And then our excess is the one that we don't run out of, is going to be the one that makes the bigger number. So our excess is S. Okay, so these are the answers that you should have provided for me. Okay, and this is what you'll be doing on your assignment. Theoretical yield is a smaller product that you make. The limiting reagent is the one that you run out of first, and the excess is the one that makes the bigger number. Okay, and that's pretty much it. Any questions about that? S, yeah, S is the excess is whatever chemical makes the bigger number. So yeah, S makes 274, so that's the excess. Okay, good question. All right, any other questions? Okay, so just to help you guys visualize, if you guys want to visualize it a little bit better, you can look at I have a diagram for you right here. 100 grams of sulfur, 100 grams of Fe. It could make 274.5, but in reality, we're not going to make that much, right? We are going to make, what was the number? I keep forgetting. Thank you. 157.3 grams. And then if you guys notice, since we didn't use up all the sulfur, that means we're going to have some of this left over. And this is what we're going to learn how to calculate next week. Okay, this is going to be the next week's calculations. Okay, but for today, you just need to figure out that you're going to make the smaller number. Okay. All right, and that's pretty much it. God bless you. Something to look forward to next week. All right, I'll give you guys the rest of the class period to work on the assignment. Let me know if you guys have any questions or if you want to check your answers. There is some balancing on it, just a heads up. So make sure you guys are looking at the front of the reactions. Okay, good luck, guys.